Hi guys, welcome back. Today we are going to focus on mass spectrometer. Now let's look at what is a mass spectrometer. The function of mass spectrometer is used to determine the number of isotopes of an element and also the mass of each isotopes. The data analyzed by the mass spectrometer will be represented in a mass spectrum like this. The number of peaks in the mass spectrum is showing the number of isotopes, while the height of the peak is showing the abundance of the isotopes. Another term for abundance is quantity or amount. Let's comparing the difference between average atomic mass and also relative atomic mass. This is the formula to determine the average atomic mass, and the unit of the average atomic mass is U, or sometimes we can write it in AMU. This is the formula for relative atomic mass. From here, you can see these two formulas actually are different. Basically, we have to determine average atomic mass, then only we can determine relative atomic mass. So the answer that you obtain from average atomic mass will be substituted into the formula of relative atomic mass. Basically, the formula for the relative atomic mass is would like to cancel out the unit. So end up relative atomic mass without unit, while average atomic mass is with the unit of U or AMU. These are the two examples that we are going to discuss. Okay, let's look at question 1. This represents the mass of the isotope, and this is the abundance of the isotope given in form of ratio. The question is asked us to determine the atomic mass. So from here we know that we will going to have unit for the final answer. Sometimes students only able to get 1 mark. Why this happen? Because examiner has no idea what the students are looking at. So always remember, you have to write down average atomic mass of gallium is equal to the formula and the final answer. This is another example as well. Students also didn't write down what they are looking at. 2 marks will be given if this is your working step. You are given the formula or calculation and then with the final answer with the unit. However, this answer can be better if you write down atomic mass of gallium. So now let's show you the best answer that I obtained. In this question, we are looking at relative atomic mass. Final answer is without unit. The abundance is given in percentage. These students seems like try to combining both formula of average atomic mass and relative atomic mass. However, the students forgot to divide with the sum of abundance, which make the average atomic mass is quite far from the supposed average atomic mass. So here there is one tips. The range of the average atomic mass should be in between the smallest and the biggest weight of the isotope. So means that will be in between 204 to 208. Another two students here showing that they are calculating for the average atomic mass. However, the mark given for the final answer because there is no unit for this answer. So in general to say, we can say that the students cannot differentiate between the average atomic mass and relative atomic mass. Now, let's look at this answer. This answer, the working step is quite good. However, the students didn't state what is he or she finding. So at here, supposedly, you have to add on average atomic mass of lead. This is a good answer. Well done to this student. Okay, let's look at another example. In this question, they are asking us to look for the atomic mass. So the final answer supposedly with the unit. At the same time, we notice that the mass is given in whole number or in the decimal places. If this is the case, we are going to choose the mass with 4 decimal places to substitute into the formula. Okay, last example that we are going to discuss. When look at this mass spectrum given, question is asking us look for the abundance. So we know we are going to use the formula average atomic mass. And here, the average atomic mass can be obtained from the constant list, which is 63.6, while the isotopic mass, in this case, we are going to use with the more decimal places here. The relative abundance is unknown, so we are going to put X. Another isotopic mass is 64.9278. And the abundance for this one will be 100 minus X. As we know, both of the abundance total out always will equal to 100. So these are the questions that we are going to emphasize in this video. Hope you get the idea and do the revision yourself again. Thank you for watching. See you again.